Hello, good morning, students. I hope you all are staying at home and are safe. But let us not forget that books are waiting for us. Grade 9 is an important year for all of you. Before we start the session, let me introduce myself to you. I am your new chemistry teacher, Smita Patil. Now, in grade 9, there are total 8 chapters. Today, we are going to study first chapter, that is language of chemistry. You must have learned balancing equation in grade 8. This chapter is little advance of what you have learned in grade 8. The content of the chapter are symbol, valency, variable valency, radicals, chemical formula, compounds. Now let us see one by one. Now symbol. Symbol is a short form of an element. A symbol represents the element. Symbol is very specific to that element. No two elements can have same symbol. For example, the symbol for carbon is C. So no other element will have symbol C. Now like the weight of man is expressed in kg, weight of element is expressed in AMU, that is atomic mass per unit. All of you know that atoms are very small, so weight of atom is measured in AMU. Now, we all know about the symbol. Who has discovered it? Long time back in 1807, Sir John Dalton gave figurative symbol. You can see the figures in the picture, like for oxygen, hydrogen, sulfur, nitrogen, then ammonia, sulfur dioxide and hydrogen sulfide. It was more difficult to remember and very complicated. So his theory was eventually discarded. Later in 1840, Berzelius suggested a system of representing elements with symbols. According to him, first letter of the element must be written in capital. Like for carbon, hydrogen and sulfur, you can see it is C, H and S, all of them are in capital. Second, first letter to be written in capital and second letter to be written in small. For example, helium, it's H capital, small e, argon, AR, xenon, Xe. And few of the names of the elements were given in Latin because Latin was the language studied by learned people at that time. So let us see the Latin name of few elements. Copper, it's cuprum, the symbol is Cu. Iron, it's ferrum, Fe. Potassium, kalium, K. Gold, aurum, Au. Silver, argentum, Ag. Lead, plumbum, Pb. Sodium, natrium, Na. Mercury, hydrargyrum, Hg. So these are the Latin name of few elements. Now let us study about valency. What is valency? The number of hydrogen atoms which can combine with or displace one atom of element or radical so as to form compound. So in valency we come to know how many hydrogen atoms it is combined with. Now metals, all of you know that metals, they are positively charged and they lose electrons, while non-metals, they are negatively charged and they gain electrons. So number of electrons lost by metal is equal to valency of that metal. The valency of all metals and hydrogen is positive. So this is very important that the valency of all metals and hydrogen is positive. Now, number of electrons gained by non-metal is equal to valency of non-metals. Now the valency of all non-metals or group of metals is always negative. Now let us consider the example of sodium with atomic number 11. So the electronic configuration will be 281. There is one electron in its outermost shell. So what it will do? It will lose one electron. So it loses one electron. That's why its valency is 1. In case of magnesium, the atomic number is 12. So electronic configuration is 282. Magnesium loses 2 electrons and so its valency is 2. In case of fluorine, which is a non-metal, atomic number 9, electronic configuration 7. So after subtracting 7 from 8, we are getting 1. So its valency is 1. As per the octet rule, we have to subtract it from 8. If it is 4 or more than 4, we have to subtract it from 8. But if it is 1, 2 or 3, it remains the same. So fluorine valency is 1. Chlorine atomic number 17, 287. Fluorine gain 1 electron and so valency of chlorine is 1. Now, to attain the stability, atoms, what they do? They lose or gain electrons. So if it is a metal, it loses electron, become positively charged and we called it as cation. When an atom gains electron, it attains negative charge and it is called as anion. Now here in this table, you can see that the number of valence electron, what is the meaning of valence electron? Electrons which are present in the outermost shell. So if the number of electron present in the last shell is 1, 2, 3, the valency remains 1, 2, 3. And if it is 4 or more than 4, we are going to subtract it from 8. Now, let us study the new concept, that is variable valency. Now, before studying variable valency, valencies are of different types. Suppose if the valency is 1, it is called as monovalent or univalent. If it is 2, it is called as divalent. If it is 3, it is called as trivalent. If it is 4, it is called as tetravalent. And there is one more type of valency, that is variable valency. Now there are certain elements which exhibit more than one valency. They are said to be, we have variable valency. Now what is the reason for this variable valency? Loss of electron from the penultimate shell. Now penultimate shell means what? The shell which is present before the outermost shell. Or you can say the second last shell of an atom. So if element exhibit two different positive valency, lower valency, higher valency. For lower valency, suffix uses OUS, and if it has higher valency, the suffix uses IC. For example, in case of iron, valency 2 is there, so it is ferrous. If it is 3, it becomes ferric. So for lower, the suffix OUS is used, and for higher, the suffix IC is used. In case of copper also, cuprous and cupric. In case of mercury, mercurous and mercury. So always remember, lower valency suffix uses OUS and higher valency suffix uses IC. Now variable valency. Now last shell of the element, if it is not stable, it starts jumping from second last shell to last shell. Now let us consider the example of copper, which is having atomic number 29. Now the electronic configuration is 2, 8, 18 and 1. So from the second last shell, one electron goes to the last shell. So the electronic configuration becomes 2, 8, 17 and 2. So in first case, the valency is 1, while in second case, copper's valency is
Electrons in an atom are arranged in a region around the nucleus, called energy levels, orbits, or shells. These orbits are represented by letters such as K, L, M, or by numbers 1, 2, 3, and so on. The number of electrons present in the outermost orbit are known as valence electrons, and the outermost orbit is called valence orbit. The maximum number of electrons that can be accommodated in the outermost orbit is 8. The elements with completely filled outermost orbit, containing 8 electrons, are said to possess an octet configuration. Such elements do not combine with other elements easily, and hence show very little reactivity. Therefore, they are said to have zero combining capacity. On the other hand, the elements with incompletely filled valence orbits have a tendency to complete their octet configuration by combining with atoms of the same or different kind. This capacity of an atom to combine with another atom is called its valency. Elements combine with other elements by losing, gaining, or sharing their electrons. For example, electronic configuration of sodium is 2, 8, 1. And that of chlorine is 2, 8, 7. Sodium finds it easier to lose 1 electron rather than gaining 7 electrons to complete its octet, while chlorine easily accepts an electron rather than losing 7 electrons to complete its octet. Thus, both sodium and chlorine have a valency of 1 as their combining capacity is 1. On the other hand, consider 2 chlorine atoms having electronic configuration 2, 8, 7, approaching each other. As you can see, each chlorine atom needs 1 electron to complete its octet. In this case, instead of gaining or losing electrons, both the chlorine atoms share 1 electron each. Hence, the valency of both the chlorine atoms in the chlorine molecule is 1, as their combining capacity is 1. Thus, the number of electrons gained, lost, or shared complete the octet directly tells us about the combining capacity of the element, that is, its valency. Let us now calculate the valency of an atom. We will first study elements having more than 4 valence electrons. Consider an atom of fluorine with atomic number 9 and an electronic configuration of 2, 7. Fluorine thus has 7 valence electrons. In order to calculate its valency, the number of valence electrons are subtracted from 8. Hence, the valency of fluorine is 1. For an oxygen atom with an atomic number 8 and an electronic configuration of 2, 6, its valency is given by 8 minus 6. That is 2. Now we will study those atoms which have less than 4 valence electrons. Consider an atom of sodium with an atomic number 11. It has an electron configuration of 2, 8, 1. Thus, sodium has 1 valence electron. For such atoms, their valencies are equal to the valence electrons. Sodium thus shows a valency of 1. It should be noted that valency of both sodium and fluorine is 1, but sodium loses an electron, while fluorine gains an electron in order to complete their octets. Hence, valency of sodium is considered to be positive, whereas that of fluorine is negative. Let us now see how the valency of ions is calculated. In case of ions, their valencies are the same as the charges carried by them and are expressed with proper signs. Species carrying positive or negative charges are called ions. Those which carry positive charges are known as cations. Some of the simple cations are Na+, Cu2+, Al3+, etc. And hence they have valencies of +1, +2, +3, respectively. The species carrying negative charges are called anions. The examples of anions are Cl-, O2-, etc., showing valencies of -1 and -2, respectively. Moreover, there exists a group.
Now let us understand about the radicals. Radicals are a group of atoms of element that behave like a single unit. So it consists of more than one element. Now radicals are further classified into positive and negative radicals. Basic radicals are positively charged, which we call them as cations. Acidic radicals are negatively charged, which we call them as anion. Now positive radical example is NH4 plus 1, that is ammonium ion. Negative radical example carbonate, sulfate, hydroxide. Now there are certain rules for radicals also. Radicals consist of a non-metal plus oxygen. For example, sulfur is a non-metal which combines with oxygen to form sulfide. Then again, sulfur is a non-metal which combines with oxygen and form sulfate. So non-metal which consists of less number of oxygen will be having suffix ite, and non-metal which contain more number of oxygen will be having suffix ate. So SO3 minus 2 is sulfite and SO4 minus 2 is sulfate. So always remember there is a rule that non-metal plus oxygen, whenever it is there, if it contains less number of oxygen, it is sulfide. If it contains more number of oxygen, it is sulfate. Now, in case of radical, the second rule is hydrogen when it combines with radical, then the suffix uses bi or hydrogen. For example, HCO3 minus 1, that is bicarbonate, which is also called as hydrogen carbonate. HSO3 minus 1 bisulfite. HSO4 1 minus, that is bisulfate. Now in case of ion, if a non-metal alone is there, it is negatively charged and it consists of suffix ide. For example, chloride Cl minus 1, bromide Br minus 1, sulfide S minus 2. Now let us see the valency chart. Now this valency chart is very important. It is given on page number 3 of your textbook. You have to learn the valency chart. Now valencies are of different types. If the valency is 1, we called it as mono or univalent. If it is 2, divalent. If it is 3, trivalent. If it is 4, tetravalent. Now let us understand about the monovalent element. Potassium, sodium, lithium, hydrogen, ammonium ion. All of them, they have valency 1. So they are monovalent in nature. While cuprous, Cu1 plus 1, Argentinus Ag plus 1, Mercurus Hg1 plus, Aurus Au1 plus, all of them are also monovalent. They have valency 1. Now calcium, magnesium, zinc, barium, nickel, cobalt, uranium. All of them, they have valency 2. So they are divalent in nature. Then cupric Cu plus 2, argentinic Ag plus 2, mercuric Hg plus 2, ferrous Fe plus 2, plumbous Fpb plus 2, stannous Sn plus 2, platinous Pt plus 2, manganese Mn plus 2. All of them have valency 2. So all of them fall under the category of divalent element. They are divalent in nature. Now trivalent means the valency is 3. For example, aluminium and chromium, both of them have valency 3. So they are trivalent in nature. While ferric Fe plus 3, auric Au plus 3, they are also having valency 3. So they are trivalent in nature. Now, if the valency is 4, it is called as tetravalent. Plumbic Pb plus 4, stannic Sn plus 4, platinic Pt 4 plus, manganic Mn 4 plus. All of them, they have valency 4. They are tetravalent in nature. So this chart is about all the positive radicals. You have to learn them thoroughly because the question may be asked in the exam to find out the valency. And valency is very important topic of this chapter. Now let us see about the valency chart of negative ions or radicals. Now chloride Cl minus 1, chlorate ClO3 minus 1, hypochlorite ClO minus 1, bromide Br minus 1, iodide I minus 1, hydroxide OH minus 1, nitrite NO2 minus 1, nitrate NO3 minus 1, hydrogen carbonate HCO3 minus 1, hydrogen bisulfite HSO3 minus 1, hydrogen bisulfate HSO4 minus 1, aluminate AlO2 minus 1, permanganate MnO4 minus 1. So all of them have valency 1, so they are monovalent in nature. Now sulfite SO3 minus 2, sulfate SO4 minus 2, sulfide S minus 2, carbonate CO3 minus 2, oxide O2 minus, chromate CrO4 minus 2, dichromate Cr2O7 minus 2, peroxide O2 minus 2, silicate SiO3 minus 2, zincate ZnO2 minus 2, plumbite PbO2 minus 2. All of them have valency 2. So they are divalent in nature. Now valency 3, that means they are trivalent in nature. Phosphate, that is PO4 minus 3, nitrite N3 N minus 3, phosphite PO3 minus 2, 3. All of them have valency 3, so they are trivalent in nature. Now tetravalent, that means valency 4. Carbide is having valency 4, that is, it is tetravalent in nature. So this was all about the negative ions and or radical. You have to learn. Let us understand chemical formula. A molecule of a substance could be represented by symbol. This representation is known as chemical formula. For example, the formula of sodium is Na, potassium K, hydrogen H2, oxygen O2. Now let us consider the example of calcium carbonate. Now calcium carbonate, it consists of one atom of calcium carbon and 3 atoms of oxygen. So it formula is CaCO3. In case of calcium hydroxide, it consists of one atom of calcium and 2 hydroxide radicals. So its chemical formula is CaOH twice. So chemical formulas are also very important. Now let us understand about compounds. Compound is a pure substance composed of 2 or more elements combined chemically in fixed proportion. Now let us consider the example of water which we use in our day-to-day life. It consists of two elements, hydrogen and oxygen. Now properties of hydrogen and oxygen are different, and that of water is different from this too. So properties of water are different from that of hydrogen and oxygen. And elements, they combine in fixed proportion by weight. Now let us understand the properties of compound. Compounds are present in definite proportion. Iron sulfide, FeS, it consists of iron and sulfur. Both of them are present in definite proportion. Compound is always homogeneous. Particles in compound are of one kind. Now, for example, if we take iron sulfide, composition cannot be varied. Hence, it is having uniform composition. Components may not be seen separately. Now, compound has a definite set of properties. Component in a compound do not retain their original property and they can be separated only by chemical means. For example, if we take iron sulfide, particles of iron sulfide are chemically combined. Hence, iron in iron sulfide cannot be attracted by magnet and does not give hydrogen gas with dilute acid. And sulfur present in iron sulfide is insoluble in carbon disulfide. So, they can be separated only by chemical means. So, these are the properties of compounds. You must have learned it in grade 8. You should know important compounds and their formulas because this can be asked in the exam. So, this was all about compounds. Now, compounds are further classified into 5 categories: acids, bases, salts, hydrocarbons, and alcohols. Now let us study them one by one. First, let us study about acids. Now all of you must have heard about hydrochloric acid. Hydrochloric acid consists of hydrogen and chlorine and the formula is HCl. And next is nitric acid. It consists of nitrogen, hydrogen and oxygen and the formula is HNO3. Okay. So, now let us study about sulfuric acid. Sulfuric acid consists of sulfur, hydrogen and oxygen. Its formula is H2SO4. So all of the acid, they contain H plus ion. Hydrochloric, nitric and sulfuric acid are used in laboratory. Now carbonic acid consists of carbon, hydrogen and oxygen. The formula is H2CO3. Now whenever carbon dioxide under high pressure is dissolved in water, it forms this carbonic acid, which is used in aerated drinks like cola, Pepsi, etc. Next is phosphoric acid. It consists of hydrogen, phosphorus and oxygen and the formula is H3PO4. Next is acetic acid, which is also called as vinegar. It consists of carbon, hydrogen, oxygen and the formula is CH3COOH. So these are all acids. You must learn the formula of these acids. Now let us consider the other category, that is bases. Now all the bases consist of OH minus ions, which is also called as hydroxide. Potassium hydroxide Potassium hydroxide consists of potassium, oxygen and hydrogen, and the formula is KOH. Sodium hydroxide, sodium, oxygen and hydrogen, formula is NaOH. Potassium hydroxide, sodium hydroxide, all of them are used in soap. Calcium hydroxide consists of calcium, oxygen and hydrogen, CaOH twice. Zinc hydroxide, zinc, oxygen and hydrogen, ZnOH twice. Magnesium hydroxide consists of magnesium, oxygen and hydrogen. The general formula is Mg in bracket OH twice. So all the acid contains H plus ion and that of base contain OH minus ion, which is also called as hydroxide or hydroxyl ion. Now let us move further and study about the salts. Now whenever acid combines with base, it forms salt and water, and the reaction is called as neutralization reaction. So let us understand the salts one by one. Lead nitrate. So lead nitrate consists of lead, nitrogen and oxygen, PbNO3 twice. Next is potassium bromide, potassium and bromine, KBr. Calcium chloride, calcium and chlorine, CaCl2. Rock salt, sodium, chlorine, NaCl, which we used for cooking food. So now gypsum, which is also called as dihydrate, it consists of calcium, sulfur, oxygen and hydrogen. The general formula is CaSO4.H2. Now this dot H2O, it is water of crystallization. What is water of crystallization? The amount of water molecule associated with that compound is called as water of crystallization. As it consists of 2H2O, it is dihydrate. Next is blue vitriol, which is also called as copper sulfate. It is having blue color. It consists of copper, sulfur, oxygen and hydrogen. CuSO4.5H2O. So it has 5 molecules of water. So it is called as pentahydrate. Next is Epsom salt. It consists of magnesium, sulfur, oxygen, hydrogen. MgSO4.7H2O. As it consists of 7 molecules of water, it is called as hectahydrate. Next is green vitriol. It consists of iron, sulfur, oxygen, hydrogen. FeSO4.7H2. 7 molecules of water, so it is also hectahydrate. Next is global salt. Global salts consist of sodium, sulfur, oxygen and hydrogen. Its formula is Na2SO4.10H2O. As it consists of 10 molecules of water, it is called as decahydrate. Next is washing soda, which we use in our day-to-day life for washing clothes. It consists of sodium, carbon, oxygen and hydrogen. Its general formula is Na2CO3.10H2O. As 10 molecules of water are present in it, it is called as decahydrate. So here are the salts. Salts generally consist of nitrate, bromide, chloride, sulfate, carbonate. So all this falls under salt. So you must learn the name of the salts along with the formula. Now next, let us understand about hydrocarbons. Now what are hydrocarbons? The name itself tells that hydrocarbon consists of carbon and hydrogen. Now hydrocarbon, here are 4 examples of hydrocarbon given. Methane, it consists of carbon and hydrogen. The general formula is CH4. Then next is ethane. It also consists of carbon and hydrogen, C2H6. So every time you have to add CH2 to the previous group. Propane, carbon, hydrogen, C3H8. Again, 1 carbon and 2 hydrogen. Next is butane. It consists of carbon and hydrogen, C4H10. So everywhere it differs by CH2 group. So in hydrocarbon we have studied methane, ethane, propane and butane. If 1 carbon is there, we have to use the prefix meth. If 2 carbon, eth. If 3 carbon, prop. And if 4 carbon, but. So it becomes methane, ethane, propane and butane. Now let us understand about the alcohol. Now, alcohol consists of OH group. Methanol, it consists of carbon, hydrogen and oxygen. Now the general formula is CH3OH. It is also called as methyl alcohol. Ethanol, it consists of carbon, hydrogen and oxygen, C2H5OH. Propanol, carbon, hydrogen, oxygen, C3H7OH, which is also called as propyl alcohol. So these are the list of hydrocarbons and alcohols. You should learn the formulas thoroughly. It is given on page number 5 of your. Now let us take the recap of the lesson, things which we have learned. We have started with symbol. What is symbol? Symbol is a short form of an element. The symbol for carbon is C, the symbol for hydrogen is H, the symbol for oxygen is O, helium He, argon Ar, xenon Xe. Now valency, it is classified into mono, di, tri, tetra and variable valency. Sodium, it is having valency 1, so monovalent. Magnesium valency 2, so divalent. Nitrogen valency 3, trivalent. Carbon valency 4, so tetravalent. Variable valency copper, mercury, silver, gold, etc. Now radicals. Radicals are what? Radicals are group of atoms which behave like a single unit. If it is positively charged, we called it as cation. If it is negatively charged, we called it as anion. And radicals are acidic as well as basic radicals. Then we have studied about the chemical formula. A molecule of a substance could be represented by symbols and the representation is known as chemical formula. Now compounds. Compound is a pure substance which consists of 2 or more elements combined chemically in a fixed proportion. Now in compounds we have seen 5 categories: acid, bases, salts, hydrocarbons and alcohol. So this was a quick recap of the lesson of what we have learned today. Please refer page number 3 and 5 of your textbook and learn the formulas thoroughly.